Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we are going to continue with solving quadratic functions, but we're going to use a really cool and powerful skill called completing the square. Now, completing the square is extremely important, not just for this, but it's also important when you have to rewrite conic sections into standard form from general form. So it's very important. And as we talked about before yesterday, there are several ways to solve a quadratic equation. Please remember that you know it's a quadratic equation if it's in the form of y equals ax squared plus bx plus c. You know that it's quadratic because, of course, the power of 2. A is the coefficient of x squared, b is the coefficient of x, and c is a constant. Yesterday we learned how to solve by using the square root method, right? And we also learned the u, right? Remember the u for substitution and factoring? Today we're going to learn completing the square. So let's do it. All right. When you guys are completing the square, guys, all right, this skill allows you to transform an unfactorable trinomial into a factorable perfect square trinomial. What is a perfect square trinomial? Well, remember, if you remember, this is a squared plus 2ab plus b squared equals a plus b squared, right? Okay. That's a perfect square binomial. It could, of course, be in negative. Now, we've been working with this for a while. Hopefully, you can really apply it to it because it's going to make your life a lot easier. We want to turn an unfactorable trinomial into a perfect square trinomial. And you can do this, guys. Okay, you can make a perfect square trinomial from an x squared plus bx by simply adding a b over 2 squared. If I have two terms, an x squared and a b and an x, okay, and I want to complete the square to that binomial, I can complete the square and make a perfect square trinomial by simply adding b over 2 squared. What happens is when you take your b, which is, again, the coefficient of x, and you divide it by 2 and square that bad boy, I promise you, you're going to have a perfect square binomial. I promise you. That's the goal. But like always, we're going to break it down little by little. So before we learn how to solve a quadratic equation by completing the square, let's just practice the simple act of just completing the square. Let me show you how to find and locate that b, how to divide it by 2, and what to do when you're squaring it, okay? So for example, guys, I want to just complete the square. I'm not solving yet. I simply want to complete the square. So step 1, identify the b. So gentlemen, what's the b here? Thank you. The b is the coefficient of x. So b equals negative 10. Step 2, find b over 2 squared. Gentlemen, don't make a mountain out of a molehill here. B is negative 10. So negative 10 over 2 equals negative 5 squared, which, leave it like that for now. Most of you are going to say, I can turn it into 25, Morrow. I know you can. Please trust me. Just leave it like that for now. So step 2, so my b in step 1, again, was b equals negative 10. And my b over 2 squared is negative 5 squared. Yes, I know that that equals 25. However, trust me, leave it like that. Step 3, add the value of b over 2 squared to complete the square. So I got x squared minus 10x plus negative 5 squared. And last step, rewrite as a square of a binomial. And this is where I want you guys to really pay attention to what I'm saying. The best way to complete the square once you have it in this form is to do as follows. Take the square root of the first term. And what's the square root of the first term? Okay. And what's the square root of the second term? Negative 5. And squared, and you're done. Now, some people in the past have said, Moro, why are you being like that? I could write this as x squared plus 10x plus 25. I know that's a perfect square. And actually, that should be a negative. I know that's a perfect square, so this is x minus 5 squared. Why is your way so great? Well, what if I had a fraction in here? Is that going to be so easy for you? No. Let me explain what I mean by that. What if I have a fraction in there? What if I wanted you to complete the square to the following, gentlemen? Plus 3x. I'm going to have to add to this b over 2 squared. So b over 2 would be 3 halves squared, right? My method, square root of the first term is x, and the square root of the second term is just basically, not basically, is exactly the inside part. So I got plus 3 halves squared. That's not bad, right? Now let's look at how some other teachers teach it, which is nothing wrong with that, and how other students want to do it, which is nothing wrong with that. You decide what you think is easier. I could rewrite this also as x squared plus 3x plus 9/4. Now you just got to do some soul searching and ask yourself a real question. How many of you are going to know what times what is 9/4, but when added together is 3? Be honest. Not many, okay? Not many. And even if you can, isn't it easier to recognize, wait a second, I have a perfect square, and I have a perfect square. So when I'm completing the square, I take the square root of the first term, and I take the inside part of the second term, and I'm done. That's why I keep this unsimplified. I do not square that last term. Me personally. It's up to you though. Now, let's practice. Let's complete the square for each. What's my b here for a? So what's my b over 2? What's 6 over 2? And then squared. Now, okay, you could put 9, but then if you train yourself of doing that, guys, when you get to a fraction, you're going to jam yourself up. I thought we went over this already. But again, you can go your way. I'm not here to dictate how to do it. Just here to teach it. Me personally, I'm going to go square root of the first term plus the inside part, and I'm done. You want to make that x squared plus 6x plus 9? Fine. Then you got to ask, what times what is positive 9, but when added together is 6, or you got to recognize the perfect square. That's your choice. For b, what's b? Okay, what's b over 2? Okay, we're going to square it. So we got x plus 4 squared. Done. Okay, for c, what's b? Negative 32. So now, what's b over 2? Negative 16 squared. So when I write this perfect square, what's the square root of the first term? And then what's the inside part of the square root of the second term? Negative 16. Done. Oh, squared. Are you getting this, guys? Okay. X squared minus 5x. What's b? Negative 5. What's b over 2? Negative 5 over 2. And I got to square it. So, what does this turn into? X minus 5 over 2, because I took the inside part, Beautiful, gentlemen. And I square it. Blagada. Done. Does that make sense, boys? Please, this is important. And I want to make sure you guys get this. All right, let's move on. Now, how to solve. All right, let's talk. How to solve a quadratic equation or function by completing the square. All right, guys. You ready? Now we're going to take the skill of completing the square, and now we're going to apply it to an equation. So I want to just go back in time a little bit. What do you think my first step here would be? Oh, what was that all about? Okay. First of all, actually what I would do here, guys, I could factor everything out by 3. I could. And actually, give me a second. All right, guys. Sorry about that. Okay. So before we do anything, we always look for a GCF if possible. Okay? A GCF if possible. And in this particular case, guys, we can take a GCF out of, whoa. We could take a GCF out of 3. Very good. Okay. So we divide by 3, we've got x squared minus 4x plus 2 equals 0. Now, do I have my x, I'm sorry, is this factorable? What times what is 2, but when I think it's negative 4? 2 times 2 is not 2. Negative 2 times 2 is not negative 2 either. So no, the answer is you cannot factor this, okay? It's unfactorable. So what you're going to do, guys, what you're going to do is, first thing, you're going to isolate the ax squared and the bx and divide by a to both sides unless a is 1. Unless a is 1. We already divided 3 to everything, so we're good there. But I want to isolate my ax squared and bx. So my ax squared minus 4x, and I send the 2 over by subtracting 2. So step 1, get the x squared and the x alone. Unless a is 1, divide everything by the a, because you need a alone, okay? You need a alone. You cannot have an a and solve by completing the square. You cannot have an a and solve by completing the square. You cannot have an a and solve by completing the square. Okay? Step 2. Complete the square by adding b over 2 squared to both sides of the equation. We know how to complete the square, but now we are solving, so you have to add it to both sides of the equation. So what's my b here? Okay, so I've got negative 4, which is my b, over 2 is negative 2 squared. This equals the negative 2 I had brought over to begin with, plus the negative b, or the b over 2 squared. So this b over 2 squared that I added must be added to both sides, because remember that we're dealing with an equation. And when you have an equation, you have to have equality on both sides. Equality on both sides means that both sides are equal. So whatever you do to one side must be done to the other side. Are you with me so far, gentlemen? Okay. Now, step 3. Factor the trinomials. Okay. What does this guy factor out to be now? X minus 2. Very good. Remember, guys, it's the square root of the first term. Square root of x squared is x. And then it's the inside part, or the square root of the second term. And the square root of negative 2 squared is negative 2. Or to make it easy, it's just the inside part. That's what comes down. You square it, and that's going to equal negative 2 plus 4 is 2. Now, guys, guess what? Now you know how to solve this using the square root method. How can I get rid of a power of 2, gentlemen? You square root both sides. So x minus 2, because the square root gets canceled out by the power of 2, equals plus or minus square root of 2. Add 2 to both sides. X equals 2 plus or minus square root of 2. And I'm sorry, that was step 4, find the square roots and solve for x. Talk to me, my brothers. Please. This is a very step-intensive situation, so please let me know. We're good? I don't see a single hand up. So that leads me to believe that you understood everything. All right, let's do this. All right, let's solve each equation, guys. First things first, whenever you see this jumbled mess, I first need a trinomial, okay? So let me go ahead and subtract x and subtract 9. So I'm going to subtract x and subtract 9. So I have 2x squared minus. So I am subtracting. So this is negative 6 equals 0. Sir, to get rid of a positive x, I have to subtract x. To get rid of a positive 9, I have to subtract 9. Sir, you do the opposite. Thank you for caring, though. Now, what's my a here? What's my a? 2. So let's divide everything by 2. So I got x squared minus x minus 3 equals 0. This is not factorable. So I am going to complete the square. First things first, get my x squared and my x alone. So my x squared, my x alone, and I add over the 3. Is everyone there? Does everyone see what I did? Now would be the time to ask me, brothers, right now. Okay? Now, step 2, I'm going to add b over 2 squared to both sides. What's my b here, gentlemen? Negative 1. And what's b over 2? What's negative 1 over 2? Negative 1/2. And I'm adding that to both sides. Are you with me? So now, this becomes x minus 1/2 squared equals 3 plus 1/4. That goes to 4. That goes to 12. So I have x minus 1/2 squared equals 13/4. I'm going to stop right there for a second. How did he get this? Well, I'm going to factor this trinomial that's a perfect square. So I took the square root of my first term, which was x, and I took the inside part, I took the b over 2, and I placed it there, and I squared it. That's how I got x minus 1/2 squared. Equals 3 plus 1/4, common denominator. That's how I got 13/4. Now, how do I cancel out a power of 2? Square root both sides. Thank you. So that gives me x minus 1/2 equals plus or minus square root of 13 over 2. And then how do I find x by itself finally here? Thank you. You add 1/2 to both sides. So x equals 1/2 plus or minus square root of 13 over 2. Talk to me. Yes, sir. You can do it like that, or you can go 1 plus or minus square root of 13 over 2. Either way. Either way, either one is correct, sir. I guess it'd be teacher's choice or test choice. Sometimes in an SAT, they'll put it all under one denominator. Sometimes they'll split it up. Depends. Does that make sense, gentlemen? You sure? Because I got to erase it. Yeah? Okay. Alrighty then. Let's continue. I got y equals x squared plus 3x minus 6. I want to solve this. So that means, first of all, I got to make that a 0. That's 0. And then this is going to be x squared plus 3x minus 6. Let's get the x squared and the x alone. So I'm going to add 6 to both sides. So I have 6 equals x squared plus 3x. Let's go ahead and complete the square. Let's add b over 2 squared to both sides. So I'm adding 3 over 2 squared to both sides. Let me stop for a second. Is everyone with me? This would be the time to ask right now, not tomorrow, not the day of the test, but right now. Okay, so now I have, this is 9/4 plus 6 over 1, that goes to 4, that goes to 24, so that's 33/4 equals, what does this trinomial turn into? X, y minus, if this is a plus inside of here, plus 3/2 squared. How do I cancel a power of 2? I square root it. When I square root it, I'm left with plus or minus square root of 33 over 2 equals x plus 3/2. How do I cancel? How do I solve for x? Subtract 3/2 to both sides. So at the end of the day, I'm going to get x equals negative 3/2 plus or minus square root of 33 over 2, or x equals negative 3 plus or minus square root of 33, all of it over 2. Either or works out fantastic. Questions, comments, concerns, problems, issues, dilemmas? Talk to me. Okay, let us continue. Okay, now let's complete the square. Let's solve. I'm going to subtract 4 to both sides to get the x squared and the x alone. Now I'm going to complete the square, so I'm going to add b over 2 squared to both sides. This factors out to become x minus 2 squared equals 96 plus 4 is 100. Square root both sides. X minus 2 equals plus or minus 10. Add 2 to both sides. X equals 10 plus 2 is, and negative 10 plus 2 is negative 8. And there you are. Yes, sir. You could have factored it, yes, but I want to practice the. Yeah, I know you could have factored, but I just want to practice the skill of getting that completing the square. Okay, what do we got to do here first for number 4? Divide everything by 9. Good job, guys. Good job. So this is x squared minus 4/3 x minus 2/9, which then I have to bring over because I got to get the x squared and the x alone. So I've got x squared minus 4/3 x equals 2/9. This is going to be a very fraction-intensive question. So please pay attention. Please ask questions. What's my b here, guys? Yes, sir. Because I didn't have an a. I didn't have an a here. If you wanted to, you could have added 2 first and then divided by a. Either way, I just like to get rid of that a immediately first, sir. Thank you. Correct. When you divide by 9, that's why you want to divide by a, because you want there to be an invisible 1 as a coefficient there for x squared. Thank you, my brother. So my b is negative 4/3. Now, guys, be careful. When you divide it by 2, remember, state change flip. This is negative 4/3 times 1/2, which equals negative 2/3. Please be cognizant of that. So, plus b over 2 squared, that's negative 2/3 squared. And I got to add that, of course, to both sides. So plus negative 2/3 squared. What does this factor out to be? First term squared, and then minus 2/3. Thank you, guys. Guys, why are you all looking at me like you're timid? Like, I don't know what to do. I don't know what to do. Where do I go? What do I... Well, how many times do I have to explain this? When we're completing a square, it's the square root of the first term. And the square root of x squared is x. Done. Then, whatever is inside, whatever your b over 2 is, that goes here. Can we please talk to me? I know you got it, my brother, but you have to admit, half the class was looking at me like I just said something in French. Does this make sense, guys? Okay. So now we have 2/9 plus 4/9, which is 6/9. Square root both sides. X minus 2/3 equals plus or minus square root of 6 over 3. Add the 2/3 to both sides. And my final answer here would be x equals 2/3 plus or minus square root of 6 over 3. Yes, sir. Come again? Sure, you could simplify that, and then you have 2/3, but now you got to rationalize. Do you really want to rationalize? Whenever I see a perfect square, my brothers, I do not hesitate. I take it out immediately. And I know that the square root of 9 is going to be 3, so I don't even hesitate. So to answer your question, yes, you could have reduced, but it would have led to more work. Okay? All right. Applying the Pythagorean Theorem. Guys, believe it or not, there's going to be applications for this. That's what the SAT is all about. And the Pythagorean Theorem, I know that we've talked about it before. I know you saw it in freshman year. I know you saw it last year in geometry. And it works only with right triangles. It only works with right triangles. It only works with right triangles. It only works with right triangles. Okay? A and B are just sides. C is the hypotenuse. You know that C is the hypotenuse because it is always opposite the 90 and it is the largest side. C is always the hypotenuse. It's always the largest side. Now, how can we use this to solve quadratics? Let's say that in a right triangle, one of the legs, you have one leg with lengths of 5 inches and 12 inches. Find the length of the hypotenuse. Well, let's see what we can do here. You have a leg of 5, you have a leg of 2. And this is my hypotenuse. So a squared plus b squared equals c squared. What's 144 squared? I mean, what's 12 squared? That was silly. Plus 5 squared. That equals c squared. This is 169 equals c squared. How do I cancel out a square? By square rooting it. So c equals, it is technically plus or minus 13, but you cannot have a negative side ever. So c only equals 13. And this, by the way, if anyone recognized this, this is a Pythagorean triple. Yes, sir, my brother. Yes, sir, my brother. If on the test you put plus or minus 13, I'd have to put half wrong because you can never have a negative side or length or distance. Thank you for asking. As always, thank you for caring. All right. Again, the Pythagorean Theorem. I have it there again for you. But whoa, what happened there? Oh, that was silly. Okay, then we are done. Fantastic. Guys, I have just a couple minutes left. Let me just do one random one. Just so, again, you could flow through completing the square, okay? Let's just say I have, we'll do an easy one and a tougher one. Let's say I have x squared plus 8x minus 3 equals 0. Okay. I got x squared plus 8x, and I bring over the 3, okay? I add 3 to both sides. Okay, so everyone with me so far in this first step? Now, I'm going to add b over 2 squared to both sides. My b is 8, b over 2 is 4. I'm adding 4 squared to both sides. There you go. This turns into x plus 4 squared. Beautiful, son. And that's 3 plus 16, which is 19. Square root both sides. X plus 4 equals plus or minus square root of 19. Subtract the 4. X equals negative 4 plus or minus square root of 19. Talk to me, boys. Please. We're good? All right. You good? All right. Thank you very much. Hope you learned a lot. God bless you. And I'll talk to you later.